Hello and welcome to yet another installment of the final exam review for Calculus 3208 presented to you by CDLI. Alrighty, we're going to talk about graphing rational functions, which is our second and final installment in Unit 3, which is very brief. But what we're going to do here is we're going to take into account a lot of the different things that we learned in our previous unit as we go through. So we're going to take all the details that we learned in our last session, which was about finding that complete analysis of a rational function. And now we're going to learn a couple of techniques to throw all that stuff together on a graph. All right, let's get down to business. We're going to look at some specifics here. Specific topics we have to look at: behavior near asymptotes. And in particular, we're interested in behavior around vertical asymptotes. For that, then we're going to look at sign diagrams. And that's something that'll be really helpful for when we go to actually graph these functions. And then we're going to do complete analyses and curve sketching of a few rational functions. All right, without further ado, here we go. So we're going to talk about function behavior near vertical asymptotes. So what is this all about? Well, vertical asymptotes, we know, they're going to be vertical lines on our graph, or imaginary vertical lines on our graph, that as we approach from one side or the other, or sometimes both, our graph is going to go off either to positive infinity like this, or it can go off to negative infinity like we see with this one down here. But the question we have to be able to answer is, coming from one side or the other toward a vertical asymptote, which way is our function going? So what we do is let's start with an example. So here we start with f of x equals x squared minus 2x minus 3 divided by another quadratic, x squared minus 9. So what we do is we write this in factored form, so that should be old hat for you guys in this course. So there's the factored form of this function. We'll notice that one of our factors in the numerator and one of our factors in the denominator are the same, so we can cancel those out, leaving us with just x plus 1 over x plus 3. Okay, so that's a good place to have gotten to. Now we can talk about the details. So once we get there, we can say that because one of our factors canceled, that's this one over here that we got rid of, that's actually going to give us a point discontinuity or a removable discontinuity, whatever you want to call it. I'm going to call it PD for point discontinuity, and that'll be at x equals positive 3, because that is the non-permissible value that's associated with this factor. Okay, we're also going to have another non-permissible value at x equals negative 3, but since that factor doesn't cancel for reasons that we've already seen here, that's going to give us a vertical asymptote. So what we have to do then is we have to look over here at the sample graphs that we have. So way over here we can see that the vertical asymptote has been already sketched for us with this fancy blue line at x equals negative 3. Okay, so how did they know, or we know, or I know, or actually whoever made these graphs know that this is the way that the graph sort of behaves on one side of the vertical asymptote or the other? Well, all we do is we look at the left and right hand limits of our function. So we look at the left hand limit and the right hand limit of our function. So these two guys right here, coming from the left, coming from the right, to look at whether our limit is going to be negative infinity or positive infinity. And if the limit from one side is positive infinity, like it is from the left here, then we're going to approach going upward. And if the limit from the other side is negative infinity, like it is from the right here, and that plus side, I don't know what's happening with those, but they never seem to translate very well into this, into Blackboard Collaborate, but that's okay. We'll live with it. So that should be a plus. Everybody knows it now. And so what happens is, as we come from the left, or sorry, from the right side, this goes to negative infinity. Now the details of how all that works out, we've covered all that in other sessions. So we'll save that for some of our examples that we get into in more detail here later on. Alrighty, so now we're going to look at something called a sign diagram. A sign diagram is basically a way for us to determine whether a certain section of our graph, or all the different sections of our graph, are either above the x-axis or below the x-axis. So what we do, first of all, is we have to identify three important features of the graph, and we take the x-coordinates of those things, we throw them onto a number line, and that helps us get our sign diagram. So those three important features are, we look for point discontinuities or removables, we look for vertical asymptotes, and we look for x-intercepts. And the reason we have to look for those three important things is because those are the three types of points where our graph can change its sign from positive to negative. We can jump over or flip around from the positive side to the minus side or vice versa at any vertical asymptote. We've seen that behavior. Should have seen a lot by now. Also, at an x-intercept, we can cross through or we might just touch the x-axis. But the important thing is that's a potential point to change sign. And also, if we have a point discontinuity, there's a chance that that point discontinuity might be right on the x-axis, unless we've already determined that it's elsewhere because we found the y-coordinate. But if we haven't, it's not a bad idea to throw that on our number line as well and check out if our sign changes there. Okay, so let's look back at our equation again. So we got to this point. And I can use this stuff right here just to test all the intervals that these 3 points that we found up here separate our graphical universe into here. So we plot each of them. We've got -3, -1, and +3, just those 3 points that we had. And then we fill in any point in each of the intervals into this equation and determine whether it's a positive answer or a negative answer. And if it comes out to be positive, well, like we have on this section and these last two, what that means is when we go to draw our graph, we're going to be up above the x-axis. Simple. And if we fill in one of the points like, say, -2 here into this equation, we get a negative answer. And when we get a negative answer, what that's going to tell us is that right here, everywhere on this interval, our graph will have to be below the x-axis. And that's good information to help us sketch the graph. All right. So what we're going to do now is take in all that information that we've just done. This is the same example that we've been working on all along here. So taking all that information, we're going to throw in finding the horizontal asymptote and the y-intercept and see if we can get a reasonable graph here. Okay, so for that particular function, let's remember that we've already sort of factored it and reduced it down to where it was equal to, and let me just double check our last slide so I remember. We had x plus 1 right here over x plus 3. So that function we said was equal to x plus 1 over x plus 3. Okay, so whether I look at this form of it or I look at this form of it and I think about horizontal asymptote, remember I compare the degrees. Since this degree and this degree is the same, then we know that the limit is going to be the ratio of those leading coefficients. So our horizontal asymptote will be at y equals 1. That's pretty easy. And to get our y-intercept, we just find f of 0. So f of 0 for this particular function is going to be at 0, 0, 0. So I've got -3 over -9, which is positive 1/3. There's my y-intercept at 0 and 1/3. Okay? Alrighty. So let's see if we can plot some information on here. So the first thing we need to know is that we have a horizontal asymptote at y equals 1. So let's go along with our theme that we've been using here for drawing fancy horizontal and vertical asymptotes using these nice colors that our textbook has been using as well. So let's go with that. So we're going to draw a horizontal asymptote at y equals 1, and that's going to run us right along here. There's our horizontal asymptote. We've already seen that our vertical asymptote for this function was at right here at x equals -3, if you look at the graphs on the far right there. So jumping back to what we were looking at -3, I'm going to plot my vertical asymptote. So let's put that one right here. And then we're going to check out the points that we can plot. So those are our two asymptotes that we have. The points that we can plot, we have a y-intercept at 0 and positive 1/3. So let's put that one on there. So 0 and positive 1/3. So that's going to be right about there. And that's about as good as I could draw a point. And let's see, do we have any x-intercepts for this function? We did. We're going to have an x-intercept at x equals -1 right there. So over here on this graph, I'm going to put a little point here at x equals -1 as well. And we also have a point discontinuity we have to be wary of when we look at x equals 3. So let's see if we can follow our sign diagram now to sketch this graph. So moving back just one slide for a second, we've got to go positive, negative, and then everything is positive after x equals -1. So we're going to go positive, negative, and then everything else is positive after that. So let's take a look here. We've got to be up above the x-axis. So I can see that I don't touch the x-axis anywhere at all on this interval. So it only makes sense I've got to be up above here. So I'm going to draw just a reasonably rough curve that's got to be above the x-axis, yet asymptotic to both of those lines, and that's about as good as I can do freehand. So there's what that section of the graph has to look like. Then we've got to be negative on our next section, and we've got to approach this asymptote right here as we saw coming from the right, heading downward toward negative infinity, like that. We saw that already. And then we're going to have to go through not only that x-intercept that we've already touched, but this y-intercept over here, And hold the phone. We're going to pause right there for a second because we knew we had a point discontinuity at x equals 3. We'll poke a little hole in the graph, and then we'll head for asymptote country as we go up this way. And so roughly, that's what the graph of that function is going to look like after we go through all the details. All right, so there's a lot to that. So let's look at a couple more examples to make sure that we've got everything nailed down here. It says provide a complete analysis of and sketch a graph for this function. Let's get factoring. X minus 1 all over x, and in this case we're going to have minus 2, and again times x minus 1. So that's nice. These two are going to go away. We just get 1 over x minus 2. So let's get all the important information. First things we should be able to find here. We're going to have a vertical asymptote at x equals positive 2 because of this factor. We're going to have a point discontinuity. Our point discontinuity will be at x equals 1 because of this factor. We're going to have a horizontal asymptote on this graph, and that horizontal asymptote will be at y equals 0. And we should know that because the degree of the top is smaller than the degree of the bottom. Then we're going to go for our intercepts. We're going to have an x-intercept nowhere, because there are no roots of this business. The only place our numerator was 0 canceled out on us, so we don't have any of those. We never touch the x-axis, which is okay because that's an asymptote anyway. And then we're going to look for our y-intercept, and the y-intercept for this function is when x equals 0. So we're just going to get negative 1 over positive 2. So we've got 0 and minus a half. So there's our y-intercept. Okay, let's plot all the important information on our sign diagram. So we've got a vertical asymptote at positive 2 right about here. We've got a point discontinuity at x equals 1. Whether or not that's going to help us, we don't know. Most of the time it doesn't, but it doesn't hurt to check. And we don't have any x-intercepts, so those are really the only two places that we're capable of even changing signs on this. So if we just sort of break our graph or our universe here into those three intervals, 1, 2, and 3, then we'll just check the sign of f as we go through. So 0 is a good place to check for our first interval. If I plug that into my original equation, I get negative 1 over positive 2, which is where we saw our y-intercept is. So that's a negative value. So we've got a negative out here. Then let's plug in a number like 1.5 to be in our second interval. That's going to give us 0.5 on the top. And we're going to get, let's see, a negative times a negative. So I'm looking at this version of the equation for right now. You can even use this one. It's probably even nicer. So let's try that. So we go with 1.5. We're going to have 1 over negative 0.5. And again, that's a negative number. Interesting. And then after 2, which is when we're at our vertical asymptote, let's plug in a nice number like 4. And so this equation is going to be positive over positive. So out here, we are going to be positive. So our sign diagram yields these results. Negative, negative, positive. Let's plot some points. Okay, so our y-intercept is at negative half. So that's right here. Then we're going to do our very best to sketch our vertical asymptote. And our vertical asymptote here is at x equals 2. So there it is. And our horizontal asymptote here is incident with the x-axis because it's at y equals 0. So there's our horizontal asymptote right along the x-axis. Then we don't have any other intercepts to plot. We'll just have to be careful about the 1 point discontinuity that we did have. We've got to be negative out on this side, so I've got to go through this point, head down yonder, and go this way, remembering that we did have a point discontinuity at positive 1. So we should poke a little hole in our graph there. And then we're positive out here in the nether regions to the right. So out on this side, I've got to draw a graph that's asymptotic to both of those guys, and it's going to head like that. And there we go. There's a graph of our rational function using all the gory details. Let's jump to our next slide. Provide a complete analysis for this function. So let's see how quickly we can get this done now. X minus 2 by x plus 2. Nothing's going to cancel out here because we just have an x plus 1 in the denominator. So important points. We're not going to have a vertical asymptote here, or sorry, a horizontal asymptote here because that degree is bigger. We're going to have an oblique asymptote. So I'm going to have to take negative 1 and divide it into positive 1, 0, negative 4 to figure out where that oblique asymptote is. So I drop that one, multiply, and add, and multiply, and add. So I end up with a negative 3 remainder, which is irrelevant. We know we have an oblique asymptote. That's our first order of business. And the oblique asymptote here is at y equals x minus 1. Okay, so let's draw that line on the graph to get started. So we've got an oblique asymptote at y equals x minus 1. So we're going to draw a line with a slope of 1 going through -1, and it should look something like that. So there's our oblique asymptote. Next thing, we're going to have x-intercepts, and we've got two of those here at +2 and -2. So our x-intercepts are at 2, 0, and -2, 0. Okay, so there's one here, and there's one over there. Alrighty, we're going to have a vertical asymptote for this function, because we do have a root here that doesn't cancel out at x equals -1. So we're going to draw a vertical asymptote now at -1, so that's going to look a lot like this. So there's our vertical asymptote. So we'll do a quick sign diagram, and really the only things we have to check here are our two roots, and they're at -2 and +2, and of course our vertical asymptote at -1. So we're going to check all that stuff out, break up our universe into 4 intervals this time, and if you plug in certain values there, what you will find out is that you're going to go negative, positive, and then in between -1 and +2, you're going to be negative again, and then positive again. So our graph goes negative, positive, negative, positive. Let's put all that together. All I have to do now is draw a line that's asymptotic to both of those guys, or sorry, a curve, not a line, that's asymptotic. One out here that's also going to be asymptotic to those things. I forgot all about my y-intercept, didn't I? It's supposed to be at -2. I'd better fix that before I get any further. Let's take this and eat it, and then we're just going to have to graph that new function, or sorry, our new idea here by looking at all this stuff, or we can take our y-intercept directly from there, and it should be at -4. Okay, that makes it even easier for us to draw. So we're just going to go right on down through there, and there's the graph of our rational function. Alrighty, here's the your turn question. Pause it and have a good try at it. Here's the solution for the your turn question, all worked out in its gory details. And let's highlight the key ideas before we clue this up. We can use all the information that we've gathered earlier to help us sketch the graph. So we can often use the behavior of the curve on either side of a vertical asymptote using one-sided limits to determine what the behavior is. We don't often need to do that because with our sign diagram and everything else we have, we sometimes have enough information. But it's helpful for us to understand why we know which way we go on one side of an asymptote. And a sign diagram provides us with information about regions of the graph that are above and below the x-axis. It is possible for the curve, now these are notes that didn't really come up in our discussion, but you should know these things. It is possible, and you've probably seen this, for a curve to cross through a horizontal asymptote at relatively small values of x, so reasonable size values of x. But we're never allowed to cross through a vertical asymptote. So it's possible to cross through a horizontal asymptote as long as eventually we do approach it, but we never cross through a vertical asymptote. And we didn't really see that much in our discussions, but I think it did come up right here in the your turn question, but that's not a big deal. Hopefully everybody learned a little bit from this, or at least had a good review of things you already knew. Thanks for watching, and if you find it useful, use it again.